Welcome back to another method of integration. This time it's called integration by partial fractions. Now there is a major difference between this method of partial fractions and the other methods we've seen so far, namely substitution, parts, and inverse trig substitution. In those cases, well, maybe not so much for inverse trig substitution, but definitely for substitution and integration by parts, we used a method which was pretty ingenious, but was fairly simple, fairly quick to implement. You may not agree with my assessment of the situation, but from a mathematical point of view, it is true. And in fact, it's definitely going to be true once you see what integration by partial fractions looks like. Integration by partial fractions is really not very elegant in a way. In fact, it is a method that relies on a few ifs and buts and a few computational difficulties. On the other hand, it is not short either, so it's going to be a bit long. So be prepared for a method which is long, which is not particularly exciting, but what is the counterpoint? The counterpoint that it's a method that, as this picture in front of you shows, allows us to compute the integral of any rational function. Notice that what you have in front of you is a rational function. The top and the bottom are both polynomials, and they may have different degrees, but certainly the top and the bottom just consists of basically combinations of powers, of integer powers of x. So what we want to ask is, how do we take the integral of a function that looks like that? Well, this method allows us, at least theoretically, to compute the integral of any function that looks like that. I'm going to come back to why only theoretically later on. Now, first of all, we know how to integrate some simple functions that look like that. For instance, we can integrate that one. That'll give us a simple logarithm. If you want to be formal about it, you want to do a little substitution. For something like that, you definitely want to do a little substitution, but again, you use a substitution, use the power rule, and you get the answer. For a function that looks like this, well, again, a little substitution plus an arctangent will give us the solution. Something like that also will require a substitution plus a power rule, a reverse power rule, and it will give us the answer. This one is a little bit more complicated. This one, a substitution will not work, and we may need to use an inverse trig substitution. So it depends on what n is. The answer may be more or less complicated. Okay, so we know how to do any one of these. If I ask you to compute any one of these 5 integrals, you should be able to do that. Oh, by the way, if you're not so sure about yourself, you may want to pause and try each and every one of these 5 integrals and make sure you get the answer correctly. Now, it turns out that this is all we need in order to integrate any rational function. So basically, the method of integration by partial fractions will allow us to break down, that's why it's called partial fractions, break down a rational function into a sum of terms, each of which pretty much looks like one of the 5 you have in front of you right now. And therefore, if we can integrate those 5, we can integrate the general rational function. Now, at least theoretically. Why am I saying that? And it's the second time I'm mentioning that. That's because some of the steps that I'm going to show you, we know mathematically that they can be done. Unfortunately, we only know at those steps that they can be done, but we don't have a general strategy for how to do it. So in other words, mathematics tells us, yeah, this is possible somehow, but we don't know how. And therefore we have to rely in those cases on the fact because of this situation, we have to rely on the fact that your questions will in fact be doable, and believe me, trust me, they will be. I will check ahead of time that all those steps which are a little bit on the iffy side can in fact be done. Not only that, but I'll make sure that they can be done fairly easily. Okay, so what is this strategy for partial fractions? Remember, we're starting from the integral of a rational function. So what we're going to do in order to evaluate that integral is we're going to do these steps in this particular sequence. First of all, we're going to reduce the fraction, the rational function fraction, to proper form if needed. What's a proper form? Well, remember, again, a rational function is a ratio of 2 polynomials. Each of them has a degree, and it's in proper form if the degree of the top is actually less than the degree of the bottom. So if we're starting from a function where the degree at the top is greater than or equal to the degree at the bottom, the first thing you want to do is reduce or rewrite that fraction so that you end up with a proper fraction. I'm going to explain to you and show you how to do each one of these steps. The second step is, after we're done that, is we're going to factor the denominator into powers of two things, either linear or irreducible quadratic factors. Okay, so what we're going to do is we're going to break down the denominator into a product. Remember, the denominator is a polynomial, it's a sum, so we're going to factor it, change it into a product, and not only that, but to a product in such a way that each of the factors is either a linear or a irreducible quadratic, or it's a power of those two. Okay. Third step will be to reverse the common denominator. Remember, when we do a common denominator among several fractions, we take those several fractions, we combine the denominators and make that into one fraction. What we want to do here is the reverse. We start from a single fraction where the denominator is a product. We're going to split it up into several fractions, each one of which only has one of those factors in the denominator. And finally, we're going to integrate each of those pieces. And as I said, those pieces are always going to turn out to be of one of those 5 forms I showed you. You may be totally confused at this point. I don't blame you. Okay, but so what I'm going to do is I'm going to go through each one of these steps in a little bit more details, but I'm going to do that through examples, and that's because it's going to be much more clear, and quite frankly, each one of these steps is much more easy to explain if I work it through an example rather than if I give it to you in generality.